Welcome back to part 3 of the differentiation series. Today we are going to do the derivatives involving inverse trigonometric composite functions. Before we can start the problems, let us go through some formulae. The first one, sine of sine inverse of x is x, cos of cos inverse of x is x, tan of tan inverse of x is x, likewise cot of cot inverse, sec of sec inverse, cosec of cosec inverse of x will be x. On the other hand, sine inverse of sine theta is theta, cos inverse of cos theta is theta, tan inverse of tan theta is also theta. Also, cot inverse of cot theta, sec inverse of sec theta, cosec inverse of cosec theta will also be theta. Moving on, sine inverse of x is cosec inverse of 1 by x, cos inverse of x is sec inverse of 1 by x, tan inverse of x is cot inverse of 1 by x. Then ahead, cos inverse of x plus sine inverse of x is pi by 2, tan inverse of x plus cot inverse of x is pi by 2, sec inverse of x plus cosec inverse of x is pi by 2, tan inverse of a plus tan inverse of b is tan inverse of a plus b upon 1 minus ab, tan inverse of a minus tan inverse of b is tan inverse of a minus b upon 1 plus ab. Also, some derivative formulas as well. D by dx of sine inverse of x is 1 upon root of 1 minus x square, whereas d by dx of cos inverse of x is minus 1 upon root of 1 minus x square. There's a change in sign over here. D by dx of tan inverse of x is 1 upon 1 plus x square. D by dx of cot inverse of x is minus 1 upon 1 plus x square. Again a change in sign as well. D by dx of sec inverse of x is 1 upon x root x square minus 1. D by dx of cosec inverse of x is minus 1 upon x root x square minus 1. Again a change in sign here. Okay, then based on these formulae we are going to start the problems. Remember what we've learned in the second session of the derivatives series, which is composite function, that continues in addition to all these formulas that we've learned. Also some trigonometry formulas that we've learned in class 11 will also come in handy. So let's start the first question. Y is equal to sine inverse of x square. Now we know that derivative of sine inverse of x is 1 upon root 1 minus x square. So when we derivate we get 1 upon root of 1 minus x square ka square, so that is 1 minus x raised to 4, but into derivative of what is inside the bracket, so that is the derivative of x square ahead, which is 2x. So the answer will be 2x upon root of 1 minus x raised to 4. Moving on, the second question, y equal to cot inverse of tan square x. So we know the derivative of cot inverse is minus 1 upon 1 plus x square, so likewise this will become minus 1 upon 1 plus tan square x ka square, which is 1 plus tan raised to 4x, but into derivative of what is inside the bracket, so that is the derivative of tan square x, which will be 2, the power comes down, into tan x into derivative of tan x, which is sec square x. So you'll get minus 2 tan x sec square x upon 1 plus tan raised to 4x. Moving on to the next problem. Now we have y equal to sec of cos inverse of 8 by x. Now can we write cos inverse as sec inverse? Yes, we can, by reciprocating 8 by x as x by 8. But with sec and sec inverse around, they will go away and you will get x by 8. So you get y is equal to x by 8. So when we derivate, we get 1 by 8 into derivative of x, which is 1. So the answer is 1 by 8. Moving to the next question, question number 4. Y is equal to tan inverse of 2 tan x upon 1 minus tan square x. Now remember, 2 tan x upon 1 minus tan square x is tan 2x, class 11 trigonometry. Tan 2x is 2 tan x upon 1 minus tan square x. So I've replaced 2 tan x upon 1 minus tan square x by tan 2x. Tan inverse of tan goes away, you get a 2x, the derivative of which is 2. Let's move to the next question. Y is equal to sine inverse of 2 cos square x minus 1. Again class 11 trigonometry. 2 cos square x minus 1 is cos 2x. But then there is a sine inverse outside. So we would want this cos to be sine. So how do we do that? We write that cos 2x as sine of pi by 2 minus 2x. Again class 11 trigonometry. Sine of pi by 2 minus theta is cos theta. So we've just reversed it. Cos theta is sine of pi by 2 minus theta. Now sine inverse of sine goes away, you're left with pi by 2 minus 2x. We derivate that, pi by 2 is a constant, the derivative of that is 0, minus 2 into derivative of x is 1, so you get 0 minus 2, the answer is minus 2. The next one, y is equal to tan inverse of root of 1 minus cos 2x upon 1 plus cos 2x. Now we know 1 minus cos 2x is 2 sine square x, 1 plus cos 2x is 2 cos square x, again 11th standard trigonometry. So tan inverse of root of, you get 2 sine square x upon 2 cos square x. These two 2's get cancelled. Sine square x upon cos square x is tan square x, which comes out of the root as tan x. So you get tan inverse of tan x. Tan inverse tan goes away, you get x, the derivative of which is 1. Moving on. Question number 7. We have tan inverse of root of 1 minus sine 4x upon 1 plus sine 4x. Again, 11th standard trigonometry tells us that 1 minus sine 2 theta is cos theta minus sine theta whole squared. 1 plus sine 2 theta is cos theta plus sine theta whole squared. So this is 4x. 4x will become 2x. Okay, so this will become cos 2x minus sine 2x the whole squared, and this will become cos 2x plus sine 2x the whole squared. The square and the root go away. You're left with tan inverse of cos 2x minus sine 2x upon cos 2x plus sine 2x. Now here's what we do. We divide the numerator and the denominator inside by cos 2x. So cos 2x upon cos 2x will become 1. Sin 2x upon cos 2x becomes tan 2x. Again, this cos 2x upon cos 2x becomes 1. This sin 2x upon cos 2x becomes tan 2x. So you're left with tan inverse of 1 minus tan 2x upon 1 plus tan 2x. Now what is 1 minus tan theta upon 1 plus tan theta? That is tan of pi by 4 minus theta. If there's a plus here and a minus here, then this would be plus. If this is minus, this is plus, this would be minus. So 1 minus tan theta upon 1 plus tan theta is tan of pi by 4 minus theta. So we write this as tan of pi by 4 minus theta is 2x here. Tan inverse of tan goes away. You're left with pi by 4 minus 2x, the derivative of which is 0 minus 2 into derivative of x is 1. So you get a minus 2. Moving on. Question number 8. You have y equal to sine inverse of a sin x plus b cos x the whole divided by root of a square plus b square. Now we just split this root of a squared plus b squared across the plus sign. Here's what you get, right? Now we construct a right angle triangle here with a acute angle alpha. We take the hypotenuse as root of a square plus b square. Okay, and so either the adjacent side is a or the opposite side is a, and vice versa. Now looking at the way this is written, because there is a upon root of a squared plus b square with sine x, I'm going to take the adjacent side as a and the opposite side as b. What does that give me? That gives me cos alpha as adjacent upon hypotenuse, which is a upon root of a squared plus b squared, and sine alpha as opposite upon hypotenuse, which is b upon root of a squared plus b squared. What is tan alpha? Tan alpha is opposite upon adjacent. So tan alpha is b by a. But what does that leave alpha for me? Alpha is tan inverse of b by a. Now, how do we use these? A upon root of a squared plus b squared will be replaced by cos alpha. B upon root of a squared plus b squared will be replaced by sine alpha. So y would become sine inverse of sine x into cos alpha, yeah, plus cos x into, this is sine alpha. So you get sine x cos alpha plus cos x sine alpha. That is sine a cos b plus cos a sine b. That becomes sine of a plus b. So that is sine of x plus alpha. Sine inverse of sine goes away. You get x plus alpha. You get y is equal to x plus alpha. But what was alpha? Alpha is tan inverse of b by a. So we replace that alpha by tan inverse of b by a. But it really doesn't matter, because when we derivative of x is 1. Tan inverse of b by a is a constant, because b and a are constants. So the derivative of a constant is 0. So you get 1 plus 0, which is 1. Now let's come to some substitution type questions. Question number 9. Y equal to sine inverse of 3x minus 4x cubed. Now we need to do some substitution in such a way that this gets simplified. Now you have to think of a trigonometry formula which is in this format, for which I put x is equal to sine theta. So when we replace x by sine theta, you get y equal to sine inverse of 3 sine theta minus 4 sine cube theta, which is again class 11 trigonometry, sine 3 theta. Sine inverse and sine goes away, you get 3 theta, but you can't just leave this in terms of theta. What do we write theta as? Theta by this substitution is sine inverse of x. So we replace this theta by sine inverse of x. Then we derivate. So 3 is kept aside, the derivative of sine inverse of x is 1 upon root 1 minus x square, and you're done. Come to the next problem. Y is equal to tan inverse of 3x minus x cube upon 1 minus 3x square. Looking at the way the formula or the expression is, the only formula that strikes you is the tan 3 theta formula. So for that we put x is equal to tan theta. That makes it 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta, which is the tan 3 theta formula. So tan inverse of tan 3 theta, tan inverse tan goes away, you get 3 theta. You get theta as tan inverse of x from the substitution. So you get 3 tan inverse of x here, you derivate that, you get 3 into derivative of tan inverse of x is 1 upon 1 plus x square. Come to the next problem. You have y equal to cos inverse of 1 minus 36x square upon 1 plus 36x square. Now we are going to substitute 6x is equal to tan theta, not x. 6x is equal to tan theta. Obviously that would make theta is equal to tan inverse of 6x, which we'll use later. Now 6x being tan theta, you know 36x square is 6x whole squared. So you'll get y is equal to cos inverse of 1 minus tan square theta upon 1 plus tan square theta, which is nothing but cos 2 theta, class 11 trigonometry again. Cos inverse cos goes away, you get 2 theta. In place of theta we are going to write tan inverse of 6x. So we get 2 tan inverse of 6x as y, which when we derivate you get dy by dx as 2 into 1 upon 1 plus 6x whole squared, which is 36x square, into derivative of 6x, which is 6. This 6 multiplies with this 2 gives you 12, and you get 12 upon 1 plus 36x square. Moving on. The next problem, y is equal to tan inverse of root of 1 minus x upon 1 plus x. Now my primary goal would be to get rid of this root. For that I'm going to put x is equal to cos theta, which obviously makes theta equal to cos inverse of x, which we'll use later. So that becomes tan inverse of root of 1 minus cos theta upon 1 plus cos theta. What is 1 minus cos theta? Class 11 trigonometry, 2 sine square theta by 2, the half of this theta, theta by 2. 1 plus cos theta is 2 cos square theta by 2. This 2 and this 2 get cancelled. Sine square theta by 2 upon cos square theta by 2 is tan square theta by 2, which then comes out of the root as tan theta by 2. Tan inverse and tan goes away, you get a theta by 2. What is theta? Theta is cos inverse of x, so you get half cos inverse of x, which when we derivate you get half into, and the derivative of cos inverse of x is minus 1 upon root of 1 minus x square. You get minus 1 upon 2 root 1 minus x square as your answer. Come to the next problem. We have y equal to tan inverse of root of 1 plus x square minus 1 the whole divided by x. Now we need to get rid of this root, because this is going to complicate your expression otherwise. So in order to get rid of this root, we put x is equal to tan theta. By doing that you get root of 1 plus tan square theta minus 1 the whole divided by tan theta. 1 plus tan square theta, remember class 10 trigonometry, is sec square theta, which comes out of the root as sec theta. So you get sec theta minus 1 upon tan theta. Now we write the sec and the tan in terms of sine and cos. So sec is 1 by cos minus 1 upon tan is written as sine upon cos. We take LCM here, so you get 1 minus cos theta the whole upon cos theta divided by sine theta upon cos theta. Cos theta goes away. You get 1 minus cos theta the whole upon sine theta. Now we apply class 11 trigonometry. 1 minus cos theta is 2 sine square theta by 2 Sine theta can be written as 2 sine theta by 2 cos theta by 2. We've used the sine to theta formula, which is 2 sine theta cos theta. Obviously in place of 2 theta now you have theta, so in place of theta you'll have theta by 2 theta by 2. So 1 minus cos theta, 2 sine square theta by 2, sine theta, 2 sine theta by 2 cos theta by 2. This 2 got cancelled, 1 sine theta by 2 got cancelled. You're left with 1 sine theta by 2 upon cos theta by 2, which is tan theta by 2. Tan inverse of tan goes away, you get theta by 2. Theta, remember, you have tan inverse of x because x was tan theta. So you get half tan inverse of x, which when we derivate, you get half into the derivative of tan inverse of x, which is 1 upon 1 plus x square. Now, the last problem, this is slightly different. Question number 14. You have y equal to cot inverse of 1 plus 15x square upon 2x. Now, this really doesn't fit any trigonometry formula that we've learned in class 11. But let's just make the cot inverse become tan inverse, which will reciprocate this. So 2x will go up and 1 plus 15x square will come down. Now, here's the trick. You write this 2x as 5x minus 3x, right? And 1 plus this 15x square is written as 5x into 3x. What does that become? That becomes tan inverse of a minus b upon 1 plus ab. What is that? That is tan inverse of a minus tan inverse of b. So that becomes tan inverse of 5x minus tan inverse of 3x. Now we just derivate this. Dy by dx will be 1 upon 1 plus 5x whole squared is 25x squared into derivative of 5x is 5 minus tan inverse of 3x, the derivative is 1 upon 1 plus 3x whole squared, which is 9x squared into derivative of 3x, which is 3. So I hope I have covered most of the inverse trigonometric composite functions. I hope you've understood this video. Until next time, goodbye.